Welcome to one of our Space Science and Technology Portals courses. The title of this course is Introduction to Space Environment and its Effect on Satellite Systems. Lecture number 1. The lecture is titled General Introduction to Space Environment Science. In this lecture, we tackle the following topics. Topic 1. Space Environment Studies and Test Mission. Topic 2. What is space environment? Topic 3. What is space weather and why do we study it? Topic 4. The Sun. Topic 5. Solar activity. Now we start with the first topic, Space Environment Studies and Test Mission. In this section, we show that Space Environment Studies and Test Mission's main function is the analysis of orbital anomalies in space environment and the prediction of anomaly occurrence during the mission. Now we move to the second topic, which is, what is space environment? This part answers a question regarding what space environment is. Space environment is a science branch that helps with understanding and addressing conditions that exist in space and affect the operation of a satellite. Space environment is highly dependent on trajectory, orbit, inclination, and time. The third topic is, what is space weather and why do we study space weather? This segment shows space weather formation and the importance of studying it. Space weather refers to conditions in the Sun and in the solar wind, magnetosphere, ionosphere, and thermosphere that can influence the performance and reliability of space-borne and ground-based technological systems and endanger human life or health. Similar to Earth weather, which can cause damage to homes and other property and disrupt our lives, space weather can cause damage to satellites, create beautiful auroras, and affect our communications, navigation, and power systems, a matter that can endanger our lives. There are three main factors that influence space weather. The Sun is the first and main factor behind the nature of space weather, so we must understand solar activities such as solar wind, solar flare, and CME. The second factor is galactic cosmic rays. The third factor is meteorites and space debris. The fourth topic is the Sun. Now we get to know more about the nature of the Sun. It is the closest star to Earth. It is located at the center of the solar system. It has the biggest effect on the environment of space. It is a ball of hot plasma about 865,000 miles in diameter, which is 100 times as big as Earth. It has a magnetic field caused by the dynamo effect. The Sun is made up of many layers, from the core where the thermonuclear reactions occur, to the convection zone where magnetic fields are generated, to the solar atmosphere where energy is released to space. The Sun releases energy that has three forms: light, magnetic fields, particles such as electrons and protons. Through this energy emission, the Sun releases enormous amounts of material. However, this enormous amount of material is so small when compared to the total mass of the Sun. Earth's space environment includes the Sun, the Earth, the region between the two, which is called interplanetary space. This environment is filled with plasma and ionized particles, light, magnetic fields. Finally, we move to the last topic, which is solar activity. The first type of solar activity is solar wind. Solar wind is a supersonic flow of high-speed charged particles continuously blowing off a star, mostly E- P positive. So we say that solar wind is a magnetized plasma that flows continuously from the surface of the sun at an average velocity of 400 kilometers a second. The sun's solar wind leads to a loss of 10 to 13 sun mass per year. Types of solar wind. The fast wind originates from the coronal holes and the quiet sun. The slow wind arises from the coronal streamers. Active regions which lie under closed magnetic loops are also a source of the slow wind. The second type of solar activity is solar flare. A solar flare is seen as a sudden variation of brightness across the electromagnetic spectrum, including X-ray wavelengths. This often leads to the acceleration of electrons and protons traveling to Earth at near relativistic velocities in excess of half the speed of light. The X-rays reach Earth and ionize some of the upper atmosphere in only 8 minutes without a warning. This is because we see the flare by light and radio waves that arrive at the same time as the X-rays. At these speeds, protons can reach Earth in around 15 minutes. The third type of solar activity is coronal mass ejection, CME. A coronal mass ejection, or CME, is a large burst of coronal material ejected away from the sun, often at speeds up to 1,000 kilometers per second, and in extreme cases in excess of 2,000 kilometers per second. This means they can hit Earth within 2 to 4 days. The bright eruptions outward are CMEs exploding away from the sun, some of which are headed in the direction of Earth. The extra plasma load can stretch the magnetosphere back out away from the sun, and when the magnetic field lines break, they snap back, accelerating electrons and protons to energies as high as 80,000 Kelvin. This part shows the effect of CME on Earth's magnetosphere. The intensity of the particle precipitation driven by a CME creates a spectacular auroral display while enhancing the electron content of the upper atmosphere. Aurora activity can be seen in most high-latitude regions, but because Earth's magnetic poles are shifted from their geographic north and south poles, the aurora is seen most frequently in Alaska and Canada in the northern hemisphere, and in Tasmania and New Zealand in the southern hemisphere. Now we have come to the end of our lecture, and we have learned how to configure an orbit in space. Thank you for your undivided attention.